Okay, join me for the Math on the Spot video. Make sure you have a piece of scratch paper. If you don't, go ahead and get it now and follow along.
We got you, Shuttle. We got you. You're coming in. We see you. Shh. Okay, we're doing okay. Oh, hi. Just playing around with the space shuttle. And the Kennedy Space Center. And you know, it's interesting. There's so much math that goes on when you're thinking about aeronautics and when you're thinking about going out into outer space. I mean, it's all mathematics, of course. But it actually reminds me of a really, really neat math question, math riddle, that involves the vehicle assembly building at the Kennedy Space Center, which is where they actually put all the various pieces and the various spacecraft, in fact, together. Let's take a look at it together and see if we can have some fun doing some stuff that just seems like it's out of space. Here we go. So, the vehicle assembly building at the Kennedy Space Center is a rectangular prism. It is 218 meters long, 158 meters wide, and 160 meters tall. Now, there are 4 139-meter tall doors, really tall doors, because of course the shuttle has to go in and out in the building, and they have an average width of 29 meters in width. So you know, those are big doors to get things in and out. Question is, what's the building's outside surface area when the doors are open? So the doors are not going to be, you know, there. They're going to be open. And what's the outside surface area? Now, the outside surface area, what that means is that we're going to look at the 4 walls and the ceiling. But we're not going to worry about the floor because we're looking for the outside surface area. So we're going to forget the floor part. We're just going to look at the 4 walls and the ceiling. But we have to subtract all the area that would be taken up by those big, big 4 doors. So lots of stuff to do here. Here is a net of the 4 walls, and you can see them. Here's the 1, 2, 3, 4 walls, and that's actually the ceiling. If you kind of fold that down, that would make up the ceiling. We're not going to count the floor. So the building dimensions we have here, and the dimensions of the 4 doors are given this way. So what we have to do is we have to find the surface area of this net, and then we'll subtract off the surface area of the 4 doors. So let's first of all take a look at the walls. So if we take a look at the walls and find the surface area of those, that's these right here, we'll notice that 2 of the walls actually are the same dimensions. So to find their surface areas, I could just take the areas of those rectangles. I could just take 2 times, and then the area of each of these is going to be, well, 218 by this length, and that length is 160. So let me just say that again. The idea is that we have this length is 218. How do I know that? Well, because check it out. This length matches perfectly with this length, and that length we can read right off of this rectangle is 218. So this is really 218 here, even though it's not written. We know it's 218. And then times 160, because that's what this is given, and then this is the exact same. So in fact, I might even put a little check mark here, so we see those 2 are the same. And that's why it's 2 times that. And what does that equal? Well, that, of course, everyone knows this. It's 69,760. And the units, of course, are meters squared. Great. Okay. Now, what about these 2 walls? Well, these 2 walls, let's see if we can figure out what their dimensions are. Well, we know that this will still be the same dimension, so it's still 160. So 160 right here. And what about this one right here? Well, 160, and we see again 150, 58. So we have 2 times 158 times 160, and of course everyone knows that that's 50,560. Duh. No, I'm joking, of course. I've thought about this a long time. Okay, so that takes care of this one and this one. Now we've got to raise the roof. Ooh, raise the roof. All right, I don't know how that goes, but okay. Anyway, here's what we do. we're going to take a look at this rectangle, and we see that there's only one of them. So the roof is only one roof. So these, in fact, let me just make it clear, these represent the walls, the 4 walls, and now we're going to do the roof. And the roof actually is going to be just one of them, because we're not doing the floor, and that's going to be 158 times 218, and that equals 34,444 meters squared, and that takes care of that. Now everything's been checked off, and so we have them all here. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So everything is represented, and so all we have to do now is just add up all these numbers. And when we add up all these numbers, we get the surface area for the whole outside of the building, and if we add them up, we see that we get 154,764 meters squared. So that's the surface area of the entire outside. But we're now going to open the doors, which means we have to subtract off the surface area of all those doors. Well, we have 4 doors, and they each have an average of dimensions of 29 meters by 139 meters. So we have to go off and find that area. And so to find that area for the doors, we're going to have 4 times the area of each of these, which is 29 times 139. And if you multiply all that together, you get, of course, 16,124 meters squared. And so now what do we do? Well, now what we do is, since these doors are going to be removed because they're going to be opened, we have to take all this surface area, which includes the doors, and now we have to subtract the doors because we want to find the surface area when the doors are open. So we have to subtract this number from this number. So what we're going to do is we're going to take 154,764, and we're going to subtract off 16,124, and when we do that, we get an answer of 138,640, and the units here again are always meters squared. And that's actually the answer. That's the surface area of the vehicle assembly building, just of the outside surface, with all the doors open. And so that is our final answer. And it is so neat, bing, that we can find something as tricky as that by just taking a look at the net, finding the area of each rectangle. In this case, we actually kind of did them in pairs, right? We found 2 times the area of one of these rectangles and 2 times the area of one of these rectangles, and then 4 times the area of all the doors. And so by doing that all at once, we're able to actually kind of compactify our work a little bit. And then by doing the appropriate subtraction, we're able to find the area, the surface area of the building's outside surface when all the doors were open. You know, there are interesting geometric shapes all around us, and we can actually measure them and see how much area they take up in terms of their surface, and we can actually study them and build new insights through that study. By studying things and making them numeric and making them quantitative, all of a sudden we see things in a richer way. Have fun seeing the world in a richer way for yourself through the eyes of mathematics, and I'll see you soon.
Thanks for watching, and I'll see you on the next one.